Hello students. Now in previous lecture we have understand about the what is influence lines and why we are using that influence lines. Influence lines is basically ordinates of a structure which is created by the moving load, and on the basis of that ordinates of influence line we are going to calculate maximum bending moment, maximum shear force, maximum reaction at supports, and from that we can design any beam. So how to calculate that maximum shear force and bending moment? We will discuss some cases in the form of examples. So for the understanding, here I have taken one of the case, and that is a simply supported beam capital AB has a span of 5 meter. Here a simply supported beam having 5 meter span. Draw influence lines for RA, RB, VX and MX for a section X at 2 meter from left hand support. Also find the value of RA, RB, Vx and Mx when a series of 4 concentrated loads 10 kilonewton, 12 kilonewton, 15 kilonewton and 8 kilonewton are acting at 1 meter, 2 meter, 3 meter and 4 meter from support A. So first of all we have to draw influence lines diagram. For that, here we have considered a moving unit load at some of the distance y from left hand support. This is AB span, and here x is equal to 2 meter from where we want to finding out our shear force and bending moment. That's why here they call that X, Vx and Mx. So this is the point where we want to find out the whole things. Now for this case we have to first draw influence lines at every point that on which our loads are acting. Like here 0 and from A 1 meter, from A 2 meter, from A 3 meter and from A 4 meter. So every 1 meter interval we have to find out the ordinates of influence lines for RA, RB, Vx and Mx. On the basis of that we can calculate the value for that. So first we have to finding out the influence lines. Now this is the influence lines for RA. So for that, at A point we have to take maximum value of reaction, that is 1. From here to here 1 meter it is 0.8. From here to 2 meter it is 0.6. At 3 meter it is 0.4, at 4 meter it is 0.2. So it is simply calculated on the basis of our mathematical formula. Like at 5 meter it is 1, then at 4 meter what is happening, at 3 meter what is happening. So from that we can calculate the influence lines for RA. Same way influence lines for RB. So in that case, first we have to take maximum reaction at B, and from the basis of we can reduce at up to A, that is 0. Now maximum shear, that Vx. So here it is our x point. It is 2 meter from here. So at 2 meter it is x upon L, that is negative, and L minus x upon L, that is positive. That value is 0.6 and 0.4. Now here at 2 meter it is 4, then at 1 meter it is 0.2. From here at 3 meter it is 0.6, then at 2 meter it is 0.4, at 1 meter it is 0.2. So this is the positive value and this is our negative value. This is influence lines for Vx. Now for Mx, so we know that it is a point load at x. So at that point it is a maximum. So x by L into L minus x, that is 1.2. So it is at 2 meter it is 1.2, then at 1 meter it is 0.6. Here at 3 meter it is 1.2, then at 2 meter it is 0.8, and at 1 meter it is 0.4. Now from the basis of this, all the influence lines diagram for RA, RB, Vx and Mx, we can calculate the value for the given loads, and that value is calculated on the basis of this influence line diagram values of ordinates. So value are calculated as for RA, that is RA is equal to 0.8 into 10. At 1 meter there is a 10 kilonewton, at 2 meter there is 12 kilonewton. So at 2 meter it is 0.6 multiply with load, at 3 meter 0.4 which is multiply with load 15, and at 4 meter it is 0.2 multiply with load acting at 4 meter there is 8. So after the calculation we will get the value of RA, that is 22.8 kilonewton. Now for RB, again here 0.2 into 10, 0.4 into 12, 0.6 into 15 and 0.8 it is multiplied with 8. So we will get RB, that is 22.2 kilonewton. Now shear at X, for this case we have two shear at 2 meter. There is positive and there is negative. So at that time we have to find out two value of shear. First one is Vx left and Vx right. For left hand side it is 0.2 multiply with 10, 0.6 multiply with 12, 0.4 multiply with 15 and 0.2 multiply with 8, and we will get 12.8 for Vx left. For Vx right it is minus 0.2 multiply with 10, minus 4 multiply with 12, 0.4 multiply with 15 and 0.2 multiply with 8. So we will get 0.8 kilonewton shear at X. It is right. Now for Mx the same thing. At A 10 kilonewton is multiplied with 0.6, 12 kilonewton is multiplied with 1.2, 15 kilonewton is multiplied with 0.8 and 8 kilonewton is multiplied with 0.4. So mx is equal to 35.6 kilonewton. Now this is the case for the given load. We will get the value of Vx, Mx and RARB. So this kind of cases is used for the analysis of moving load on the bridges. The another case, there is only two loads moving on the our bridge. So what we will get? First, two wheel loads 12 kilonewton and 20 kilonewton with fixed distance 2 meter between there, and 12 kilonewton leading load. So it is 12 over here, crosses a beam of span 8 meter from left to right. Draw the influence lines for shear force and bending moment for a point 3 meter from left hand support. So somewhere over here 3 meter from left support A. Fix, it is fixed distance that given by them. Now find the maximum value of shear force and bending moment. Here we have to find out only shear and bending. So no need to draw influence line for RA and RB. Now this is our beam and these two loads are given. So what we have to do? We have to just calculate ordinates for these two loads only. So we have to make only the 2 points where forces are acting. So first we have to draw influence lines diagram for Vx at C. So at C point it is x upon L, it is 0.375, and L minus x upon L, so it is 0.625. Now what is done over here? Here 12 kilonewton is leading load and 20 kilonewton is somewhere over here. So here 20 kilonewton and here 12 kilonewton. So this is our 5 meter distance. At 5 meter it is 0.625. Then what is happening for 3 meter? So we will get the value of the ordinate for 12 kilonewton load. So influence line for shear force at 3 meter from left. Maximum positive shear will occur when the 20 kilonewton load is just to the right of C and 12 kilonewton is ahead of it. Ordinates under the 12 kilonewton is 3 upon 5 multiplied with 0.625. So we will get 0.375. Now at C point, the shear at C, that is maximum, and the value is multiplied with these two ordinates. 20 multiplied with this 0.625 and 12 multiplied with this, and summation of that we will get the maximum shear, that is 17 kilonewton. Now influence line for bending moment at 3 meter from left support. So this is our beam and at C there is maximum. So we have to first find out this point, that is x upon L into L minus x, that is 1.875. Now suppose here we are going to consider that this two load is in the portion of AC, then the value of this getting over here, and suppose it is in CB portion, then the value something over here. So we have to finding out the maximum bending moment will occur when the load are in the position shown in the figure. So ordinate under 12 kilonewton, that is 3 by 5 multiplied with 875, that is 1.125. Now the maximum bending moment, that is 20 into 1.875 plus 12 into 1.125. So we will get maximum value of moment, that is 51 kilonewton into meter. Now another case for the UDL, and for the understanding of this UDL we have to take consideration that it is the average value of that UDL. Now what is happening? An UDL of 12 kilonewton per meter and 3 meter length, this is crosses a simply supported girder of span 10 meter from left to right, the span 10 meter. Draw influence line for shear force and bending moment at a section 4 meter from left hand support and find the maximum shear force and bending moment for this case. So influence line for shear force 4 meter from left for this case, that is at 4 meter x upon L it is 0.4 and L minus x upon L, that is 0.6. So here it is maximum. Now the UDL is having 3 meter length. So from here to here at 3 meter value is 0.3. So this is the shaded area for the our UDL ordinates for shear force. So maximum positive shear force at C will occur when the tail of load at C, मीन्स यहाँ पे अगर लोड होगा, यहाँ से आगे होगा तो ऑर्डिनेट्स डेफिनेटली कम ही आएंगे, क्योंकि ये वैल्यू 0.4 ही है तो ये शायद 0.1 ही आएगी. बट यहाँ पे अगर हम लोड इस तरफ रखेंगे तो ऑर्डिनेट्स की वैल्यू मैक्सिमम आएगी. सो यहाँ पे हमें शेयर मैक्सिमम मिलेगा. नाउ ऑर्डिनेट्स अंडर द हेड समवेयर ओवर हियर, देन it is 3/6 into 0.6, so we will get 0.3. Now maximum positive shear force at C, that is W into area of this shaded part of influence line. So the load, that is 12 kilonewton per meter, and the value of this 0.6 plus 0.3 divided by 2 means it is the average value, and the area means we have to multiply this length. So we will get maximum shear force, positive shear force, that is 16.2 kilonewton. Clear? Now for the bending moment, what is done over here? Influence line for bending moment at 4 meter from left. So for this case we have to take ordinates in that position that it is similar height. So what is done over there? X upon L into L minus X, that is 2.4. So value at C1, that is 2.4. So this is our main value. Now we have to take A1 and BB1. So this is our influence line for bending moment, and we can consider this UDL somewhere over that. For portion AC, C over here, and for portion CB it is 3 minus C over here. This is A1 and this is B1. So what is happening? For the maximum area under the UDL of AA1 must be equal to BB1. हमको ये दोनों सेम चाहिए. Then what is happening? AC upon CB, that A1 C into CB1, that is 4/6, and this is C upon 3 minus 6. So we will get the value of, after solving this, that is C is equal to 1.2 meter. Now in AC portion, UDL length of that UDL is 1.2 meter. Now AA1 is equal to 2.8 divided by 4 into 2.4, that is 1.68, and BB1, that is 1.68. Now we will get the same value of that coordinate. So now we can calculate the maximum bending moment on the basis of this equal ordinate height. Now moment at C for maximum, that is W into area of shaded part. Now there is a two shaded area for AC portion and BC portion. So what is happening? 12 into, this is load, and the area, that is 1.68 plus 2.4 divided by 2 into length, that is 1.2. Again 1.68 plus 2.4 divided by 2 into length, that is 1.8. So after calculating this, we will get the maximum bending moment, that is 73.44 kilonewton into meter for the UDL. Now this is the cases for determinate beams. All the beams are simply supported, but in this case we have indeterminate structure also. So for the understanding of that indeterminate beams, we will discuss that things in our next lecture. Till then, thank you very much.